All right, hey everyone, it's Glenn again. It's been a while, but today I figured I'd talk about a topic or address some questions that I very commonly get, especially as some of my projects have gotten increasing attention over the years. So today we're gonna actually talk about 3D printing and airsoft. And by that, I mean like, how is it durability wise? How well does the gun perform? How much does it actually cost? Because a lot of people are under the impression that 3D printed airsoft guns are very cheap. And the reality is something like this, like my M7 here that I've been running for the past year, it's not as cheap as a lot of people think that it would be. So let's just go ahead and get into this. Okay, so the first thing that I really want to talk about here is durability. A lot of times I get asked about how durable is your 3D printed airsoft gun? And to that point, I will say that I first started building and exclusively running 3D printed airsoft guns back in 2017. So it's been about 3 years of me running 3D printed airsoft guns. You can actually go back into my channel and you can see the very first 3D printed M7 that I ever did, which was back in August of 2017. So it's been quite a while for me to run 3D printed guns, and I have a pretty solid track record, very many different platforms that I've built and I've actually run. And as far as durability goes, it's surprisingly not too bad. 3D printed guns do hold their shape very well. They feel pretty solid. Like anytime I've actually handed this gun to somebody else at the field, I'm like, hey, you can check it out. They're like, wow, it actually feels pretty good to hold. Like a lot of times they're expecting it to just be this creaking kind of, you can sort of bend it and stuff like that. But the reality is, if you did a good job designing the platform, whatever it is that you printed, it will hold its shape pretty well and it will feel pretty good to hold. It'll also be significantly lighter than those injection molded plastics or your full metal bodied guns, just because you don't really fill all of the cavities inside of your 3D print with solid material. But at the same time, depending on your wall thickness, your gun is going to be a lot less BB resistant than some of your other standard platforms. Like, let's say you have a Ares Amoeba Honey Badger, one of those plastic bodied guns, the I think they call it nylon reinforced bodies or whatever. One of those gets shot, you're not gonna care. Like it'll be fine, even if you're at CQB ranges. Like somebody rounds a corner and pops your gun, it'll probably be fine. Not quite the case with 3D printed thermoplastics. So if it takes a BB shot at close range, there is a chance that the body gets ruptured. You could crack the outer shell. Like you can have like a dent in your airsoft gun, and it's just not as BB resistant. That's just the reality of these 3D printed guns. Now, is your gun gonna completely fail just because somebody shot it? No, your gun will probably still work. But by the same token, like, do you really want to run around the field with a 3D printed gun which has damage to it? Like, some people don't mind that their guns have been shot up or they have a lot of scratches on them and stuff like that, but the reality is 3D printed guns will take more damage from BB impacts. They're just not as durable. Now, as far as like, let's say you drop your gun. Well, your standard airsoft guns can break from being dropped too. 3D printed guns are no different. The only difference is that 3D printed guns are much lighter. Okay, so there is, by virtue of weight, you do have, in some ways you have better chances of survival, and other ways you do not. It really depends on how you dropped your gun and where you dropped it. Like this gun by itself, what you see here, this M7 that I have, that I'm using as my example here, this gun only weighs like 3.5 pounds. If I dropped it, that's only 3.5 pounds worth of force of the gun just falling on the floor. It's very different from, let's say I have a 416, one of those VFC 416s. Those are pretty heavy. You drop one of those, that's quite a bit of force to fall on the floor. And that's depending on how you dropped it, it could break. So the reality is that it's really not too much different from your average airsoft gun. But if you, let's say you tripped and fell on your gun though, your metal body gun is probably going to stand a lot better chance of not being damaged than this plastic bodied gun, because you're now applying your weight onto a much structurally weaker, quote unquote weaker platform than a standard gun. And the reality is it's probably going to fail. But by the same token, would another airsoft gun survive if you fell on it? So that's really all I have to say about the durability of a 3D printed gun. I think as a TLDR, it's a little bit less durable than your average airsoft gun, but it's not fragile to the point where, if I do even the smallest thing to it, it's just gonna come apart at the seams, it's gonna spontaneously combust or something like that. So it's really not as bad as people think it is, but at the same time, you need to understand what you're getting into if this is something that you really want. All right, so the next question that I often get is, how well does the gun perform? And this really will depend on how well the platform is designed. If you've done your research and really ironed out how you've designed your hop-up unit and how it interfaces with whatever gearbox or HPA engine that you're using, you're gonna have great performance, okay? If you spend the time to do it, it'll perform just as good as any other well-tuned gun that you have. So this gun in particular, I've spent, it's been several years now, just kind of refining the way that I've built the HPA unit as one piece with a hop-up unit. And so basically I'm getting perfect alignment with how the nozzle lines up with my bucking. I've really been able to tune how tight the bucking lips are so that the transition between loading and firing is very consistent. So from a performance perspective, this gun shoots pretty much just as good as any very well-tuned Polar Star would shoot. At the end of the day, you're still using the same HPA engine, you're still using the same, or not quite the same, but you're using a barrel and a bucking that's any other builder would have access to. The only difference is that I've been able to adjust my bucking lips, or the tightness of those bucking lips and the transition point between the lips and the bucking nub to just the way that I really like it, so that the performance is nice and consistent. Now, specific to this gun in particular, you kind of have to address some of how is the magazine feeding into the gun and how even is your feed pressure, but you have to deal with that with any other custom gun, right? Or any other build that you're working with. So you don't get your mid-cap syndrome or whatever. So at the end of the day, this is still an HPA powered airsoft gun. You get the exact same performance out of it. And I have let several people try this at the field, and they've always said, okay, yeah, this gun shoots really good. And it's not really any different from any of the other well-tuned HPA guns. So from a performance perspective, you're looking at just as good performance as any other gun. So the last topic that I really want to talk about here in regards to 3D printing and airsoft, and it's often something that people are very surprised about, it's actually the cost of building something like this. So a lot of times people are of the impression that, 3D printing, it's super cheap, right? So that gun has to cost less than $50, right? You would be very, very wrong. And people are often very surprised when they contact me for a commission or something like that. And I tell them, hey, the way that you spec'd out this gun, you're looking at 4 figures. And that's right, I said 4 figures. So this gun that you see in front of you, by virtue of components alone, this is a very expensive gun, okay? So we'll kind of go over everything that's inside of this, okay? So front to back, we have a 8-inch suppressor, foam filled, whatever. It's like, there is an AEG spring in here, but you could just kind of fill it with whatever material that you wanted to. But the first cost point is this flashlight right here. All right, this is a UTG laser flashlight combination. It's about 50 bucks. Okay, so 50 bucks onto the bill of materials. So we'll move back a little bit. Next item on the list, you can't really see it, but it's in there. You have your barrel and your bucking. Okay, so I'm buying these parts retail. So that means I have to pay for tax, I have to pay for shipping, and I'm not getting like warehouse or wholesale pricing for these components. So the hop-up bucking is about $10, Maple Leaf hybrid bucking or hot shot, whichever one you prefer. Then you have the barrel, which is an aftermarket barrel. So again, this is an Action Army 6.03 300 millimeter inner barrel. At the time of building this, those barrels were about $30. Right now they're actually $36, so more expensive. We keep moving back. We hit this. So that's just a cheap Aimpoint red dot. It's a clone actually, so it's 30 bucks. You can get those on Amazon, whatever. This sight on the back is actually an APS Rhino sight, but it's purely cosmetic. It doesn't serve any purpose. So, I mean, if you wanted to include it, it's like what, 30 bucks? Kind of expensive for just a cosmetic piece, but it is what it is. Then we have these magazines. These are Action Army 50 round VSR 10 magazines. Very nice magazines, very consistent feeding, but they are also pretty expensive. You can find them between $12 to $16 depending on where you get them. So beneath that, we have this guy right here. So for those of you guys who are not very familiar with CO2 systems, this is actually the Wolverine Wraith CO2. So it's got like a quick change CO2 system that allows you to run your HPA engine off of CO2. Really cool, right? Well, at least it's cool until you look at how much it costs. So the Wraith itself is about 80 bucks, I want to say. And then the regulator, because you have to regulate your CO2, is about anywhere between, like, I want to say it's like 120 bucks to 150 bucks. I'm not quite sure what the price was on that. I'm going to say that it's 120 so that that'll make things easy for me. So the Wraith CO2 with the regulator, $200, okay? That's already adding in quite a bit of cost. You can see why this adds up very quickly, and it's nowhere near as cheap as people think that it is. Anyways, we're going to keep moving back. So we get to the HPA engine. How much is an HPA engine? Well, the Gen 2 Inferno Premium Edition, which has the external fire control unit, a little programmable PCB card that comes with your HPA engine. That is about, I want to say it's like 360 bucks. So yeah, $360 plus $200 for this Wraith. And then you have your hop up and barrel, that's another $40. This guy right here, dual source kit, so you can run HPA on a remote line if you want. That's 60 bucks. Magazine $12, light $50, sight $30. Like, you can see why this adds up so quickly. So the total that you're looking for, like, let's estimate $30 for all the filament, the screws, the wiring that you have to do, and then you have to solder like everything to the safeties, electronics switches. You have to wire your trigger in there. Let's say that that's $30, not including any of the labor that it takes to build one of these, okay? So if we just add up all of the costs, here's what we get. $30 for the hardware. You have the Inferno for $360, so that is $390. The Wraith plus the regulator for the CO2 system, that's $200, so we're now at $590. Hop up and barrel is $40, so that is, what did I say before? 590 plus 4,630 plus dual source kit 60, so 690 plus the magazine, let's say $15 per magazine. $705 plus the light, which is $50, so $755 plus $30 for the site, $785. And then we have, let's see, $785 as your raw total. That does not include the cost of building it on your own time. It does not include the cost of shipping. It does not include the cost of tax. Like, the amount of cost that goes into this as you build it just compounds and compounds and compounds. So this gun, as you see it, is, you can very easily reach into the 4-figure digit range just by virtue of like components being $800. Let's say let's say I undervalue my labor to build one of these and I only charge like $100. The reality is, like, what kind of tech charges $100 for the amount of time it takes them to build a fully custom airsoft? That's insane. But I digress. The point being that you're looking at, I'll just round it up to $800 for the material cost. Let's say shipping is $30 for all the components, which is undervaluing it again. But let's also say that tax is 10%. So $80 worth of tax, and then what is it? What did I say for shipping? $30 for shipping. So you're already above like $900 just to build one of these guns, and then you have to pay for labor, and then I have to ship the thing out. So that's even more shipping. So the reality is, 3D printing these guns is just not cheap, especially if you're using HPA, especially if you want to really deck it out with like dual source and CO2. Now, if you just wanted to 3D print a shell for like an AEG body, sure, it would be a lot cheaper, but it's also a lot harder to redesign a gun around a full version 2, version 3 gearbox than it is a small cylinder, which is your HPA unit. So which one do you value more? Do you value your time, or do you value cost efficiency and the size limitations of like full-size gearboxes and batteries and stuff like that? So that's really all I have to say about 3D printing and airsoft. As far as, it's really not very cost efficient, and it's quite expensive to commission custom work. Now, if you are in that position where you say, hey, this gun doesn't exist on the market and I really, really want one, I'm really willing to pay for one, you really need to understand that what you're buying into is not going to be cost efficient. It's not going to be quite as durable as your average airsoft gun that you might be used to. And while the performance might be up to par and or better with some really high-end custom guns, it's just, you just really need to understand what you are getting into. Can you forego the durability, or are you self-sufficient enough that you can fix your own gun, or do you have your own 3D printer that you can reprint or redesign some of your parts if you break them, so on and so forth. So hopefully this video is helpful in explaining why 3D printing is kind of where it is as far as how much it costs and what you're looking at in terms of actually owning one. So if you guys have any other questions, feel free to leave them down below. I'll do my best to answer them. And I think that's it for now. See you guys later.